All right, let's talk about something every single Java developer has to master: typecasting. Honestly, getting this right is one of those key things that separates clunky code from clean, reliable code. It's how you avoid those super frustrating errors. So, let's dive in and demystify this thing.
So, if you've ever written Java, you've been there, right? You hit that type mismatch wall. You try to stick a number with a decimal into a variable that's only meant for whole numbers, and nope, Java just slams the door in your face. It can feel like the language is just being difficult, but that pickiness, it's not a bug. It's actually one of Java's biggest strengths. And here's why. Java is what we call a strongly typed language, and thinking of it that way changes everything. It's not about being difficult, it's about being safe. It forces you, the developer, to be crystal clear about your intentions. And the payoff is huge. It catches potential mistakes way early, during compilation, long before your code ever has a chance to fail in front of an actual user.
Okay, so here's the best way to picture this. Just think of every variable you create as a special container. An int variable, that's a container perfectly shaped to hold only whole numbers. A double container is for numbers with decimal points. A string container holds text. Each one has a specific job, and you can't just cram the wrong stuff into the wrong box.
So what happens when you actually need to move data between these different containers? Well, that's exactly what typecasting is for. It's the official process of, you guessed it, pouring the contents from one container into another. It's how we work with Java's rules to get things done safely and effectively.
Now, when we're talking about the basic building blocks, what Java calls primitives, like numbers and characters, this whole pouring process can go one of two ways. One is totally automatic, and the other one you have to do by hand. Let's break down how that works.
And this chart really lays it out perfectly. On the left, you've got widening. Think of this as pouring water from a small cup into a giant bucket. It's completely safe, right? You're not going to spill a single drop. That's why Java's cool with doing it for you automatically. But on the right, you have narrowing. That's like trying to pour the entire big bucket into that tiny cup. It's risky. You're probably going to lose some data. It's going to spill over. And because of that risk, Java makes you do it manually.
So, widening casting, sometimes called implicit casting, is the easy one. It's a total no-brainer. If you're putting a value from a smaller container into a bigger one, like taking an int and putting it into a double, Java knows for sure there's no risk. It just handles the conversion for you, completely behind the scenes. You don't have to write any special code, it just works.
But going the other way? That's narrowing or explicit casting. And this is where you have to step in and give Java direct permission. You have to say, hey, I've got this. Why? Because you're pouring that big bucket into the small cup, and something might get lost. For instance, if you convert a double to an int, you're going to lose everything after the decimal point. So you have to explicitly tell Java, yep, I know this is risky. I accept that I might lose some data here.
So how do you actually do it? Let's look at the code. First, you start with your value in the big container, like 9.78 in a double. Then, to pour it into that smaller int container, you have to signal your intention. You do that by putting the target type, int in this case, in parentheses right before the variable. And what happens? Well, the 0.78 gets chopped off. It's gone. The cast works, but you've accepted that loss of precision.
Okay, casting numbers is one thing, but this whole idea gets way more interesting and powerful when we start talking about objects. Here, our container analogy gets an upgrade. We're not just thinking about size anymore, we're thinking about how generic or how specific a container is.
And this all comes down to inheritance. So let's imagine you have a poodle class, and it's a specific type of dog. Upcasting is when you take your specific poodle object and put it into a more general dog container. This is always safe because every poodle is a dog, right? Downcasting is the reverse. It's taking an object from the general dog container and trying to say, hey, this is actually a poodle. And that's a bit trickier. This table really breaks it down. Upcasting, going from specific to general, is always safe, and you do this to make your code more flexible, to write a method that can work with any kind of dog, not just poodles. Downcasting, on the other hand, is risky because you're making an assumption. You only do this when you absolutely need to use a feature that only a poodle has, something a generic dog doesn't.
Okay, and this is where we enter the danger zone. Because downcasting is powerful, but if you get it wrong, if you try to force an object into a container where it just plain doesn't belong, your whole program can come crashing down.
And this is the error that will stop your application dead in its tracks, the class cast exception. What makes this one so bad is that it's a runtime error. The compiler can't warn you about it. It just blows up while your code is running, which is the worst possible time.
So what triggers it? It happens when you lie to the compiler. Let's say you have an object that is, in reality, a cat, but you're storing it in a general animal variable. If you then try to downcast it and say, dog, my animal, Java's going to throw this exception at runtime. You just can't force a cat to be a dog. They're just not compatible. So how do we stop this disaster from happening? How do we downcast safely? Well, luckily, Java gives us a secret weapon for this exact problem. Before you ever try a risky downcast, you have to check what the object really is, using the instance of operator. It's your safety net.
Let this be your new programming mantra. Seriously, burn this into your brain. You use a simple if statement. If my animal instantiates dog, then and only then, inside that block, is it safe to do the cast. This simple little check is what prevents the class cast exception and makes your code predictable and strong.
So let's tie it all together, shall we? First, remember Java's strictness isn't a bug, it's a feature for safety. Second, the container analogy is your best friend. Use it. For the basics, widening from small to large is automatic and safe. Narrowing from large to small is manual and risky. And finally, for objects, the powerful tool of downcasting must always be guarded by an instant subcheck to keep your app from crashing.
Which brings us right back to our very first question. Now that you've seen how casting gives you this controlled power, while the type system acts as a safety net, what do you think? Is Java's strictness a limitation? A bug? Or is it actually an essential feature for building really solid, error-free software? Something to think about.